Welcome to this tutorial on Kubernetes secrets. In this video, we'll explore how Kubernetes helps us store and manage sensitive information securely. Secrets are essential for handling passwords, authentication tokens, and certificates in your containerized applications. Let's dive in and understand how Kubernetes makes sensitive data management safer and more efficient. Kubernetes secrets are special objects designed to store sensitive data separately from your application code and pod specifications. This separation is crucial for security. Secrets help keep sensitive data out of container images, which significantly reduces the risk of accidental exposure. The data in secrets is stored as base 64 encoded strings. You can use secrets in two primary ways: by mounting them as files in your containers, or by injecting them as environment variables. This flexible approach ensures your sensitive information remains protected while still being accessible to your applications when needed. Kubernetes provides several built-in secret types to handle different kinds of sensitive data. The opaque type is the default and most common, used for arbitrary user-defined data like passwords and API keys. The Docker configuration type is specifically designed for storing Docker registry authentication credentials, allowing your cluster to pull images from private registries. The service account token type manages authentication tokens for service accounts within the cluster. Finally, the TLS type is used for storing TLS certificates and their associated private keys, essential for secure communications. Each type serves a specific purpose and helps organize your sensitive data appropriately. Let's look at how to create a secret using a YAML manifest. You start by specifying the API version as v1 and the kind as secret. In the metadata section, you give your secret a name, such as my secret. The type field is set to opaque for general-purpose secrets. The data section contains your sensitive information, where each value must be base 64 encoded. In this example, we have a username encoded as YWDMI4 equals, and a password encoded as CGFZC3DVCMQXMJM equals. Remember, base 64 encoding is not encryption, it's simply a way to represent binary data as text. The actual security comes from Kubernetes access controls and optional encryption at rest. Once you've created a secret, there are three main ways to use it in your pods. First, you can mount secrets as volume mounts, which makes the secret data available as files in your container's file system. This approach is ideal when your application reads configuration from files. Second, you can inject secrets as environment variables, making the sensitive data directly available to your application through the container environment. This is convenient for applications that expect credentials through environment variables. Third, you can use image pull secrets to authenticate with private container registries. This allows Kubernetes to pull container images that require authentication. Each method has its use cases depending on how your application consumes sensitive data. Here's a practical example of using secrets as environment variables. In your pod specification, under the env section, you define environment variables that reference your secret. For instance, you create an environment variable named db_userNAME. Instead of hardcoding the value, you use value from with secret keyref. You specify the secret name as my secret and the key as username. Similarly, for db_PSSWORD, you reference the same secret but use the password key. When the pod starts, Kubernetes automatically populates these environment variables with the decoded values from your secret, making them available to your application securely. Now let's see how to mount secrets as volumes. In the volumes section of your pod specification, you define a volume with a name like secret volume. You specify that this volume comes from a secret by using the secret field and providing the secret name as my secret. Then, in your container specification, under volume mounts, you mount this volume to a specific path in your container, such as /etc/secrets. The read-only field is set to true for security, preventing the container from modifying the secret data. When your container runs, It will find the secret keys as individual files in the mounted directory, with the decoded values as the file contents. To ensure maximum security when working with Kubernetes secrets, follow these best practices. First, enable encryption at rest for your etcetera database, where secrets are stored. This protects your sensitive data even if someone gains access to the underlying storage. Second, implement role-based access control, or RBAC, to restrict who can view and manage secrets in your cluster. Only authorized users and service accounts should have access. Third, avoid hard-coding secrets in your container images or application code. Always use Kubernetes secrets instead. Finally, rotate your secrets regularly by updating them periodically. This limits the window of vulnerability if a secret is ever compromised. Following these practices will help you maintain a secure Kubernetes environment.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.